Okay, today I'm going to go through one question from this paper which I missed in my run-through. So this is the Physics International A-Level, Edexcel Unit 5, which covers thermodynamics, radiation, oscillations and cosmology. And someone noticed that question 16 wasn't in any of the videos that I posted. So I'm going to go and do it now. So I had it ready and I must have just missed it because I actually put the questions in, kind of combined all the simple line of motion type questions together. And for some reason, I didn't include this when I did the other space questions. Okay, so if you haven't watched the rest of the run through, I've already done 5 parts, multiple choice and then short sections in topic sections. So go back and find it in the same playlist and you can watch them. And if you like any of the videos, please share them with friends who are taking Edexcel. It's also useful for the Edexcel linear students because there are more exams for the international paper, and this is equivalent to the year 13 content of the advanced linear paper 2. Okay, so these are definitely worth using for practice before the linear students have paper 2, which I think is in a while. Whereas Unit 5 is June the 4th, so you've got all next week as well to prepare. Okay, so question 16 reads as follows. Cepheid variable stars are used by astronomers as standard candles. Okay, you need to know what a standard candle means, and you've got to know the standard definition for a standard candle. A standard candle is a stellar object of a known luminosity. Okay, so this will get you the 1 mark. Have a look at the mark scheme if you're not sure of how you should do it, and use mark schemes when you've done papers to mark them yourself and look at the key words that you must include for your definitions. Part B says the luminosity of such variable stars, Cepheid variable stars, vary periodically. Okay, now there is a linear relationship between the period and the mean luminosity of a Cepheid variable star as shown. So basically someone has gone and measured all the mean luminosities of Cepheid variables and compared them to the period of the Cepheid variables. So it's not one Cepheid variable, it's all of them. And notice that there is a straight line correlation for all this type of stars. So the more luminous they are, it seems, the longer the period in days on the x-axis. Okay? And the luminosity, you've got to realize, is compared to the luminosity of the sun. So it's relative luminosity. Okay, you notice that the y-axis is not linear. It's not a linear scale. Okay? So the variation in luminosity, L, of this particular Cepheid variable star with time is shown below. Okay? So in other words, any Cepheid variable has the luminosity which kind of varies over days. Okay? Now you can work out the period of this variation by counting how many peaks or complete waves you have. So I'm going to just trace over it. There's 1 complete wave. Here's 2 complete waves. Here's 3 complete waves. And here is 4 complete waves. So that's 4 periods. Yeah. So the period will be 20 days divided by 4. So for this particular Cepheid variable that we're talking about, it would have a period of 5 days. And 5 days then, you can look on this first graph to find out that 5 is here, and you can trace it up and then across to find that the luminosity will be 2000 greater than the luminosity of the sun. Okay, so it's 2000 sun luminosities. So you could think of this as the unit that they're using, the luminosity of the sun. Okay, so I'm prefacing this as the introduction to the question that they're going to ask. They're going to ask you to do what I've just done. Okay, so they want you to show that the mean luminosity of this particular Cepheid variable star is about 8 times 10 to the 29 watts. Well, all you've got to do is use the second graph to find the t, like I showed you. Then look at 5 days on the second graph. Yeah, so you've got the period as 5 days. You'll get 2 marks. Okay, so you counted a multiple number of periods. Don't just count one for accuracy. You should count as many as possible. Then you use this first graph to find where 5 days was, as I showed you. Then you multiply it by the luminosity of the sun, and the luminosity of the sun is given here. So you put that into the equation, and it's going to be 2000 times the luminosity of the sun, which gives you a value of 7.66 times 10 to the 29, which is approximately equal to 8 times 10 to the 29 watts to one significant figure, which is what they asked us to show. Okay? Part 2 then says, when viewed from Earth, the mean intensity of this Cepheid variable star is 5.1 times 10 to the minus 4 watts per square meter. So now intensity is given by this equation, which is luminosity divided by the spherical surface area that it has spread out over. Yeah, so, and that will be from Earth. So the distance from Earth would be the value of r. Okay, so determine this, the distance of this Cepheid variable star from Earth. So we want to find out r. So we know I, and we know L. We just worked it out above. So we know I, we know L. The only thing we don't know is r. So change the subject to make r the subject of the equation. Divide the luminosity, which we calculated in part 1, by the intensity. And of course, there's the factor of 4 pi to consider from the equation. And it gives you an intensity of 1.195 times 10 to the 32, and that's for r squared. So r squared is equal to that. So r squared is equal to that, but you want r, so you square root that. Yeah, so you could have just done, we could have just done that in one go by making that the square root, and there's the answer to 4 significant figures, but you would then round it up to 2 significant figures. Yeah, because the data provided is given to 2 significant figures. Okay, and that's the run through that I forgot to do. I apologize, it should have gone with the other space questions, and here's the mark scheme for you to be able to have a look at how they are grading or marking this particular question. Well, thank you for the person who pointed out to me that I'd missed it, and I will add it to the others in this playlist. Don't forget, if you find my videos helpful, that I would like you to like each video, because it really helps with the way YouTube works, and share it with anyone else who you think would benefit from watching these videos, and make sure you're subscribed so you know when future videos are going to be uploaded. So my main focus will be on Unit 5 for the IAL, and the next video someone had noticed I hadn't done June of 23, so if I get a chance I will do June of 23, and if you notice there are any recent ones which I haven't done, let me know and I'll see if I can fit them in. But obviously I work full-time as well, so please bear with me, and I will do as many as I can for different exams. I'm also adding linear exams to my repertoire because I'm now teaching linear Edexcel, and I'm also teaching modular this year. Okay, so there will be more linear exams. Unfortunately, someone has written me an email from YouTube, one of you guys watching, asking if I can upload papers. That's not a service I offer. The only service I offer is the run-throughs, because I use them for my own teaching anyway, and I find it a very useful way of using YouTube. It allows students to learn beyond the lesson, and they don't always need to see me to find answers. So it kind of maximizes the time that they can get of understanding the underlying concepts. So I don't do the physics run-throughs, the question run-throughs, just to give you the answers. I do it to explain physics to my own students, and they can improve their own understanding once they're at home. So then in class, they can ask me more specific questions. I find this a very efficient way of creating learning opportunities. Okay, well, thanks for watching. Hopefully catch you in the next video. Bye for now.